Exponents in algebra or math are the little numbers that are written up in the top right corner. And this means multiply 2 by itself 2 times, or 3 to the second power, or 3 to the third power, or 3 cubed. So what this means is, for example, 3 cubed is the same thing as saying 3 times 3 times 3. This exponent number tells us how many times to multiply the base number by itself. Or 4 to the second power would be the same thing as 4 times 4. Or 7 to the fifth power would be the same thing as 7 times 7 times 7 times 7 times 7. The exponent number tells us how many times, 5 in this case, 1, 2, 3, 4, 5, how many times to multiply this base number by itself by. There's a couple of special cases for exponents, and that is 2 to the 0 power, or 3 to the 0 power, or x to the 0 power. Anything raised to the 0 power is just 1. Doesn't matter what it is. It could be x or y to the 0 power. It's going to be 1. And the other case is a base number, 4 in this case, raised to the first power. Well, that's just simply going to be 4. Anything raised to the first power, or anything to the first power, is just that base term itself. So those are important. You just have to kind of memorize that and remember it as you advance and as you begin to work with these exponent terms in equations. So let's look at how we do that. There's something called the first law of exponents, and that tells us how to handle situations when we're multiplying. Say, for example, 2 to the second power multiplied by 2 to the third power. The first law of exponents tells us to add the two exponent numbers together. So this becomes 2 to the 2 plus 3 power, or 2 to the fifth. And this will only work if the base term is the same. So we can also have x cubed times x squared. As long as this term, x in this case, is the same, we can use the first law of exponents. This would become x to the 3 plus 2, or x to the fifth. How about x to the fourth multiplied by x to the minus seventh? And notice that you can have negative numbers for your exponents. So there's really nothing tricky about this. We just have to follow the first law of exponents. This becomes x to the 4 plus a minus 7, which is written just as minus 7. And that becomes x to the minus third. We could try another one. How about x to the minus second times x to the sixth? We're going to rewrite this as x to the minus 2 plus 6. And that's the same thing as x to the fourth. Let's do one more, a little more complicated, just to kind of see how this works. How about if we use the distributive property x squared times the quantity 1 plus x to the fifth? We saw how to use a distributive property earlier, and it's no different when you're working with these exponent terms. We're going to multiply the term outside of the parentheses by each one of the terms inside. So in this case, we have x squared times 1 is x squared, and x squared times x to the fifth is going to be x to the 2 plus 5. And I can rewrite this by saying, let me just rewrite this x squared term and plus x to the 7th. And that's pretty much the answer there. We could do one more just to just to practice. How about if we had x to the minus 3rd times x to the 0 times x to the 5th. So we should simplify this before we get started, and we have to remember that anything to the 0 power is just 1. So really this whole term can go away. It's just 1, because when I multiply 1 by anything, it's just the same thing itself. So I'll rewrite this as x minus 3 times x to the 5th. And that's going to be x minus 3 plus 5, or x squared.